Assalamu alaikum. I'm Fatima Tayyab from University Mechatronics department, and my roll number is 180896. So our task is to write the code for the line in which the line follower have the following features. It should follow a black line using the three IR sensors, and instead of sensors, I had added three push buttons or logic states, and it also have a feature of a climate controlled air conditioning system using temperature sensor. I had used LM35 as it is a requirement of this task, and the temperature of the LM35 is displayed on the LCD. And also we have to control the speed of the motor through PWM, and the speed of the motor is indicated on the LCD, which is connected with the which is connected in the series with the motor. And the next task is to detect the hurdle and display its result on the LCD. And for this purpose, I had used variable resistor with the ADC. And the next task is, which is task number 5, is to connect the sensor and the motor driving system to the one controller and displaying system on another controller. So moving towards my simulation. For the motor control, I had used L923D motor driver. It has four inputs and two enables. Input 1 and input 2 is connected to enable 1, and input 3 and input 4 is connected to enable 2. Then we have to drive the uh, motor, the left motor. We have to set the bit of enable 1 and one of the two bits of enable, input 1 or input 2. And to drive the right motor, we have to set the bit of enable 2, and we have to send we also have to set the input 3 or input 4 bit pins. So these are the sensors or logic states which we have used to send the command to over port J. And this is the LCD which is connected to the temperature sensor and also obstacle sensor. This resistor shows the obstacle detection, and through ADC we had connected port F to LCD. Whenever obstacle is less than 30 centimeters, it will show that hurdle ahead, and then over two motors will stop. And through this circuit, we have controlled the speed of this motor through PWM, and its speed should be shown on this LED. So this is the Arduino Mega 2560, and it is Arduino Uno, the Mega 328B. It is 16-bit microcontroller, and it is 8-bit. Now I had uploaded the hex file in the slave, and the code for the master is written in the source code. So when the temperature is above 50, it will show the temperature. uh, it is 57 and it is 61, and when I change the resistance, the distance will be changed, and it detect that there is a hurdle ahead, and that means the distance is less than 30. Then the motors will stop this, and this shows the speed of the motor is changed with the PWM. When it is 0, it has PWM of OCR0 is equals to 30. That means its duty cycle is 30, and there is a blink in the LED. And when it is 1, the motor will rotate faster. There is a larger blink. In its code, first we have add the input output library, and then included the IO library, and usual delay is used to uh, add delay in this, and FCPU is actually a function for delay, and 16 mm, megahertz is its crystal frequency, and interrupt function is used to add the header for the interrupt, and LCD 3 to 8p is actually the header file which I had included in this to run the LCD to display my pictures on the LCD, and these are the pins for the master. In this first function, I have some data character which is used to make it the master, and this function is used to initialize the master. In my main function, I had first make the port J0 as input, and H port as output, and then I had initialized the LCD function in which it shows distance, and likewise it has sent 10 to the temp array, and 10 values to the distance. In these values, my mid sensor is on, and the output at port H is 0x1D, and when the right and middle sensor is high, or only right sensor is high, the left motor will rotate, and this value is sent to the port H, and this will send values to the motor driver. And likewise, when the left and the middle sensor is high, or only left sensor is high, then the right motor rotates, and these values are sent to the port H, which will then send to the motor driver. And when all the sensors are high or all the sensors are low, then the port H will is 0, and no motor will rotate. Here I had initializes the LCD, and it is an initializing function which I will call later. In LCD display temp will be displayed on LCD, and through this calculation we have ADC value of 9.3, ADC value which is divided by 9.3, and through this we have this value of V sent to the temp, and then we have set the cursor, and then this temp value will go to the LCD which will be displayed, and then we had displayed Celsius to tell the temperature unit, and then to clear LCD command write 0x01 is used, and then there's a delay of 2000 microsecond, and then the function of ADC initial P is called, and then the LCD display distance displays on LCD, and again the process is repeated, and the digital uh, and then the value of the distance, which will be read by the port H, sorry, port F, will be read by the LCD, by the ADC, and then to the LCD. Through these, we are initializing the ADC registers. First, we have set the reference 0 and mux 2 and 0. And in this step, we have select the channel that we have selected ADC pin 5. And in this pin, we had enable ADC and ADC conversion interrupt activated through clock 118 through these pins. And in this step, when we set the bit of ADSC, SC means start conversation. ADC conversation is started, and through this ADC will wait for here to complete the conversation. Complete the conversation, and in this the ADC interrupt flag will be high, will be set, and these are the same functions, but here we have selected the pin 5 for the temperature, and these are the functions for the master, in which data send is used to send data or receive data. These functions are same at port B. When we clear the bit of SS, SPDR is equals to 0, and through these conditions, port C will get the value of SPDR in port B, and at port B, SS is selected, and these are also the function to enable the master master out slave in, master and slave out functions. And now moving towards my report. In this first, I had explained the task of this objectives of this task, and then the explanation in theoretical explanation. I had first describes what components and how I had used them in my simulation. So first, I written about LM35. It is basically a temperature sensor device, which is commonly used to measure the temperature with an electrical input comparative to the temperature in Celsius. And it is also better than thermistor, which is also a temperature measuring device. It is used in industries and also for commercial purposes when we are needed to measure the accurate temperature. And it has 3 pins. Its VCC pin is directed to the 5-volt input, and pin 2 is selected as an output, and pin 3 is grounded. And then we have a motor driver, in which we have 13 pins: input 1, input 2, enable 1, and I had already explained in my simulation. And then there is the working of the line follower. So these are the conditions which would be applied on the port port A and port K and port J. So these are the steps which I had in which I had explained about the variable resistor with the ADC. So to detect the obstacle, I have used a variable resistor. In case of ultrasonic sensor, in this different resistances shows the different distances from the obstacle. Means I have used ADC, which is analog to digital converter. It is the value of the analog signal is read and then converted to the digital form. The ADC converts an analog input voltage to a 10-bit digital value through successive approximation. So the minimum value represents ground and the maximum value represents the voltage on the AREF in minus 1 least significant bit. Optimally, a VCC or an internal 2.56 voltage reference voltage may be connected to the AREF pin by writing to the reference and bits. So basically, in our code, when I write the reference selection N, where I had used reference selection 0 bit, and through this I had sending the 2.56 internal voltage to the to my ADC. The internal voltage reference may thus be decoupled by an external capacitor at the area pin to improve noise immunity. So in my code, I had also used the ADC SRA, which is the ADC control status register A, and in this register we are writing 1 to its bit 6, which is ADSC and ADC start conversation. By this we are starting the conversation, and ADSC will read as 1 as long as the conversation is in progress. When the conversation is completed, it returns to 0, and bit to writing 0 to this bit has no effect. In the later step, we set the bit 4 of ADC SRA, which is ADIF, ADC internal flag. By this, the conversion of ADC completed. In the function of ADC, setup ADC of the code, we set the ADEN, ADIE, ADPS0, ADPS1, where ADC S2 to 0 of ADC prescaler represent ADC prescaler 0, 1, 2 are used to select the value of input log and crystal frequency of ADMUX. So basically, ADMUX is the ADC multiplexer selection register, and in this bit, bit 7 and 6 select the reference voltage for the ADC. Bit 5 select whether high or low bits are used, while the bits 4 and 0 select the analog input connected to the ADC. In the code, we set the bit 6, which REF0 reference selection bit 0, which is used to provide the input voltage same as VCC. In this, mux 0 and mux 2 is also set, which are used for different inputs. So TCC R0A is actually a timer or counter control register of timer 0, where COM0A1 is used to write the value. That means it is used to control the waveform generator, where VGM00 and VGM01 are used to select the mode of operation. OCR0A is the output compare register, and TCC R0B, it is also timer or counter control register timer 0, which is basically used to select the clock, where CS00 and CS02 are the clock selectors. These are actually used in PWM, which is phase. So these are actually used in PWM, which is pulse width modulation or pulse duration modulation. It is a method of reducing the average power delivered by an electric signal by affecting by effectively chopping it up into discrete parts. So in this, the average value of voltage fed to the load is controlled by turning the switch between supply and load on and off at a fast rate. So these are the steps for the PWM. Now moving towards LCD, it is used to display the values obtained from sensors or different or microcontroller. We had to interface the LCD with microcontroller for interfacing. We had first to see its datasheet or pin configuration. So I had used the A16 by 2 LCD in my simulation, and this and in this VSS is used for ground, VDD is used is connected to 5 volt, V node is connected to contrast. Through this pin we can adjust the brightness of this LCD, and RS is the register. Through RW we can read or write the on the LCD, and E is used to enable the LCD, and D0, D1, D2, D3, D4, D5, D6, and D7, these are data bus. In this our data is carried, and then these values will be displayed on the screen. And in our hard form, these LCDs also have an A and K pins on it, where for common anode we have common cathode, we have to ground the cathode, and 5 volt is supplied to the anode. And for the common anode, we have common anode we have to ground the anode, and 5 volt will be supplied to the cathode. And these are the calculations for the left turn, right turn, and these are the bitwise configuration which I had used in my simulation. And this is the block diagram in which three sensors are connected, and motor 1 is and motor 2 receives the information from the AVR, and obstacle sensor and temperature sensors in values are also fed to the AVR, where AVR is a microcontroller, and it is the flow chart. In this, first an input is obtained. If our inputs are same, then this will be terminated and the motors will off. And if our inputs are not same, then it will check if the motors, if the left one, sorry, these are the sensor inputs. If the left sensor is on, then it's turned left, and if it is not on, then it turns right. And at this condition it will check another conditions. If it is not left and also it is not right, then the mid sensor is on only. If it is on only, then it will move forward, or if and then after these steps it will check the temperature, and after that check the distance. If the distance is less than 30, it will move to the move to check again the inputs, and if inputs have are same, then the motor will goes off. And then at this step it will again uh, check the distance, and again it is the source code of my simulation. It is the code for slave. So in this task I have we have basically learned how to connect motors and motor drivers, their pin configuration, and their setup with the microcontroller, and how to write code for line follower in C language, and also to make its circuit, and also to write code for the LM35, which is a temperature sensor, and obstacle detection using ADC. So that's all. Thank you.